Okay, this strategy for factoring, it works when you have a quadratic trinomial where the leading coefficient is not equal to 1. Okay, so we need a different strategy when the leading coefficient is not equal to 1. So we notice that we're in this case because the leading coefficient here is a 2. Okay, so we notice that we can't take out any factors of 2 because the middle term doesn't have a factor of 2. We can't take out any factors of x because the last term doesn't have any factors of x. So this is how we know that we're definitely in the slip and slide case. All right, now this is an algorithm that works. So it's just a process that you need to know and kind of have memorized to be able to factor this. All right, it's a little weird at first. But it's pretty clean once you do a couple. It's not super terrible, but it's a little weird if this is your first time being exposed to it, okay? All right, so here's how it works. Basically what we're gonna do, the slip part, is we're gonna slip the coefficient down to the back, okay? And we're gonna do that by multiplication. All right, so all we're gonna do is multiply 2 times negative 28. And then I'm gonna rewrite a new trinomial without the leading coefficient. So we're kind of throwing it in the back by multiplication. So our new trinomial is going to be x squared minus x minus 28 times 2 is going to be 56. All right, so that's the first step, is when the leading coefficient isn't 1, multiply it with the last term, okay, and then rewrite a brand new trinomial. And now, when you take a look at this new trinomial, we notice that we're in the basic case, right? So now the leading coefficient is 1. So we know how to handle this. So we can factor this. This is going to end up being one positive number and one negative number. So we need two numbers that multiply to negative 56 and then add up to negative 1. All right, the two numbers that would do that for us would be positive 7 and negative 8. When I multiply them, you get negative 56, and when you add them up, you get negative 1. Okay, so that's the first step. Now, what we need to do is slide this guy back in. Okay, so this is going to seem a little weird, but since we multiplied the 2 in the first step, what we're going to do now is bring them back. So we're going to divide, we're going to bring them back by division, but we're only going to do that to the constants. All right, now in each case, two things could happen. Either the fraction will simplify or it won't. So if it simplifies, we'll just write the simplified number, and if it doesn't, then we're going to slide them up into the front. So if we notice here, let's look at the first one. 7 over 2 would not simplify to an integer. Okay, so what we're going to do is we're going to take it and we're going to slide it into the front. So we're going to end up with 2x plus 7. That's the first term. And then for the second one, we're going to make sure it doesn't simplify. 8 over 2 does simplify. So we're going to say x minus 4 is our second term. All right, and that's how we factor trinomials that are not with a leading coefficient of positive 1. All right, so again, it seems a little weird at first, but once you understand the process and understand the algorithm, it's a very quick and easy way to factor what would be a complicated trinomial. All right, let's take a look at another one. So here there's no GCF. We have a quadratic trinomial, leading coefficient of 8. That's how we know it's slip and slide. Let's slip this guy over to the back. So we're going to rewrite a new trinomial without the leading coefficient because we're bringing them to the end here. So we have m squared plus 6m. The middle term will never change. And then 8 times negative 5 would give us negative 40. All right, so we take the original trinomial and turn it into a basic one. Okay, that's the idea. And we do that because now we know how to handle this. So what we can do is find two numbers that multiply to negative 40 and add up to 6. And the two numbers that would do that for us would be, I think, positive 10 and negative 4. All right, and then we can't just forget about the 8, so let's bring them back. And we'll see if it simplifies or if it doesn't. Let's see what happens. So if I was to keep writing these factors, 10 over 8 does simplify. So let's see, we're going to do m plus 5 over 4. And then in the other one, 4 over 8 does simplify as well to 1/2. But when we have factors, we never want to leave it as a fraction. Okay, so we're going to have to slide these denominators up to the front. Okay, so we're going to take the 4, we'll slide them up to the front. So our final factor will be 4m plus 5. And then we'll take this denominator of 2 and slide this guy up to the front. So this is going to be 2m minus 1. Okay, and then we're done. All right, so we had to slide the denominators twice because when they simplified, it wasn't an integer. All right, we only want integers in our factors. Okay. All right, similar idea on number 19. However, 19 has a GCF. All right, so we're dealing with all even numbers, so we can take out a factor of 2. All right, so let's start by doing that. So we have the factor of 2. We'd be left with 3w squared minus 14w plus 16. And now we're basically ignoring that 2, and we're just going to focus on this. We know it's slip and slide. It's a quadratic trinomial with a leading coefficient of 3. All right, so let's see. We're going to do a couple things here. Let's rewrite the new trinomial. So I'm going to take the first term, multiply it with the last term, and then we can rewrite it. So we're going to do, what would that be? W squared minus 14w, but writing it without the leading coefficient, and then plus, what's that, 48? Okay, so now let's factor that. So the 2 is just hanging out for the ride. This is a GCF. So I need two numbers that multiply to 48, add up to negative 14. What would do that for us? Definitely two negatives, so I at least know that. So it's going to be w minus, because you have to multiply to positive and add to a negative, and I think the numbers that would do that would be 6 and 8. Okay, and let's not forget about our 3, so let's bring them back in. We'll divide it by 3, and if it simplifies to an integer, we're good. If not, we'll slide them. So let's see. We have the 2 hanging out. 6 over 3 just becomes 2, so we have w minus 2. 8 over 3 doesn't simplify, so let's take this 3 and slide them to the front. Oops. So we'd end up with 3w minus 8, and then we're done. Okay, all of our factors have only integers. The first factor simplified to a negative 2, the other one didn't, so we had to slide them up. All right, let's do one more. So here, between 16, 24, and 8, we have a factor of 8. That's our GCF. Let's take him out first before we analyze this. So if we take out an 8, we'd be left with 2k squared minus 3k plus 1. Okay, and then we'll slip and slide this guy, so we'll bring the 2 down here. We'll rewrite the polynomial, so the factor of 8 just kind of hangs out. So we're left with, oops. I'm going to rewrite the new polynomial now. So we want to do k squared minus 3k plus 2. And then we can factor the basic trinomial that we just created. So two numbers that multiply to 2 add up to negative 3. I think that would be 2 and 1. They're both going to be negative because you have to multiply to a positive and add to a negative. All right, and then let's bring our 2 back. So we'll divide the last term by 2. This one doesn't simplify, so we're going to have to slide them. And this one does simplify. That's going to end up being 1. 2 over 2 is just 1. So we'll get 8 is our GCF. Then we have 2k minus 1. And then k minus 1.